Okay, so for your ionic formula notes, remember ionic bonds start with a middle, okay? There's definitely the most rules for these, all right? There's the most going on. So first, write down these rules, all of them. You need everything. I know this bottom part down here is cut off. It says the ions charge. That's these last words down here. Okay, so if you need to go ahead and pause and write all that down, you will want these rules in your notes for sure. Also, this is for writing the names. The last one was for writing the formulas. This is for writing the names. Again, you're going to want to write these down. These are your rules, and I'm going to go through these rules as I show you examples. It's just easier that way, but you'll want to have these in your notes. So also this whole slide, put those in your notes for your rules for writing the names. And then this is also one that you're going to want for your notes. It's a helpful slide that tells you a lot of the things that I'm going to say as I'm explaining these examples. It just reminds you of those things and what to check for, because there really is a lot of moving parts and a lot of things going on with these. So also make sure that you write all of this down. So you should have 3 slides that you should write pretty much everything down word for word. And then I'm going to X out of this and get you some examples to go by. Okay, whenever you're doing ionic compounds, you have to have this polyatomic ion sheet. You'll never be without it, all right? You're never going to have to memorize these. You'll always have access to the sheet so that you can look up these polyatomic ions, all right? So I'll talk more about these in just a minute. You're going to need your periodic table so that you can look all these up and their charges. But before we start, we've done this before, so I'm going to remind you that this first group right here is the +1 column. This group is the +2. That means all of these elements in group 2 have a +2 charge. So they always form +2 ions. This group, excluding boron. So boron falls on the top of the stair step. So I'm going to put a +3 up here, but you need to realize that that really starts kind of right here. Aluminum and gallium have a +3 charge always. Okay, so it's kind of a weird group. Remember, this one was Na, and then here was our -3 group, -2, and -1. Okay, don't worry about the noble gases, they don't form ions. All right, I'm going to go ahead and tell you this as well. This middle group, this D group right here, they can form more than one ion. So you can make yourself a note. They form multiple ions. What that means is that you're going to have to give them Roman numerals when you name them. And I'm going to show you some examples. But this middle group form multiple ions. So they need Roman numerals. Okay. All right, so this first example is just a basic binary compound. It has just 2 elements in it, magnesium and bromide. The way that you can start is to write the 2 ions. Okay, so first we have magnesium, all right, and magnesium forms a +2 ion. Let me show you how I know that. We just wrote it down, right? Here's magnesium right here, and he's in the +2. That's how I knew the charge that he made. And then our other element in that formula is bromine. He's right here. See, he's in the -1 column. So that means he has a -1 charge. So I'm just showing you where these charges are coming from. So there's our magnesium. Here's our bromine, -1. Okay, these charges, this charge right here, and this one, I know it's a 1, understood, okay? They're going to come down. They're superscripts right now. That means they're written up high. They're going to come down and become subscripts, which means they're written down low, and you're going to drop those little charges. So only the numbers come down. The plus and minus do not. All right, so my final answer, the 1 comes down to magnesium. So there's technically a 1 here, but we don't write 1, so I won't put anything. Then I'm going to write bromine. And this 2 comes down and across to bromine, and it goes right there. So the superscripts become subscripts. They come down and across. Okay, so that's my formula right there for magnesium bromide. This right here is no part of the actual answer. You can do this if it helps you see what numbers to put down here, but this is the only answer you need and the only correct answer. This really has nothing to do with it. It's just a way to show you where these numbers are coming from. All right. Okay, so for the next one, calcium is Ca. So if we look right here, calcium is in the +2 charge. So I know it has a +2. Okay. So 2+. Then we have phosphate. If it ends in ATE, that's a clue that it probably didn't come off the periodic table. See, bromide ended in IDE, and you'll remember we changed the one on the periodic table. We changed the second one to IDE. Well, that's what happened. This one doesn't end in IDE. So that's your clue. You need to look for it on this other sheet. It's our first time to use this sheet. Okay. So we're going to go find phosphate. Okay, look. There's my word right there. Phosphate that I was looking for. Okay. Here is the formula for it here. Okay. PO4 with a -3. So I'm going to go write that over there. You'll always have access to that chart. PO4 with a -3. All right, so when I'm writing my final answer, remember, these are going to come down and across. So I'm going to write Ca. The 3 is going to come down and across and drop that charge. I'm going to put a 3 there. And then I'm going to write PO4. Now, whenever polyatomic ions, which is what phosphate is, that come off that table I just showed you, get charges or numbers, these numbers right here, when they get these numbers that are greater than 1, they need parentheses around them. Okay, so I'm going to put some parentheses around phosphate and put that little 2 out there. They only need those if they're getting a charge bigger than 1. Okay, so there you go. All right, for the next one, iron, you'll look that up. It's Fe. All right, now let me show you though where it is. So iron, Fe, where are you? Here it is. Okay, he's in the middle. Need Roman numerals, multiple ions. That means you just can't go look up his charge because they can have more than one charge. All right. So this is where you get the charge right here. If they're in that D block, they're going to have these Roman numerals that tell you their charge, and they'll always be positive. These Roman numerals always go to the first one, and they're always positive. So 3+. That's telling me that has a 3+ charge. And then sulfide is sulfur. Okay, sulfur has a -2. Just showing you real quick right here. That's how I know. There it is, -2. That's where you look that up at. And then they just crisscross again. So Fe is going to get that 2. And then sulfur is going to get that 3. 2 and 3. That's my answer. All right, for this one, again, you see the Roman numerals. That means chromium is in the middle. And that 2 is telling you chromium's charge. It always tells you the first one's charge, not the second one. Oxide is oxygen, so O. And if I look up O, here it is. It has a -2 charge. Put that there. All right, so this is the first one that we've had where, look, the 2 would come down, right? And then the O, and then the 2 would come down. Okay. With ionic compounds, you can't leave that like that. If these subscripts will reduce, then you have to reduce them. So when I say reduce, that means that what number goes into both of these numbers equally? 2. Okay, so 2 goes into 2 one time, 2 goes into 2 one time. If they will reduce, you have to reduce them. And so your final answer, would just look like this instead, because these 2's, once they come down, reduce. And so your final answer would look like this. All right, so you have to reduce if they will reduce. All right, again, this is a metal in the middle, nickel. Must be because it's got the Roman numerals, and that's a 4. In Roman numerals, that's 4. So I'm going to put this up here, 4+. Sulfate, look, it ends in ATE. That tells me that it comes off this other one over here. And they're in alphabetical order. So right here, sulfate, SO4 with a -2 charge. That's where you go look that up. SO4 with a -2 charge. Okay. Now they're going to come down and across. So nickel, it's going to get the 2. And then sulfate, now look, it's a polyatomic ion. It's getting a charge bigger than, put it in parentheses, and put that 4 on the outside. Now, these subscripts that come with these polyatomic ions, like here it was a 4, it was a 4 up here, you are not allowed to do anything with those except copy them down exactly like they are off the table. You don't reduce them, you don't move them, they don't go anywhere, you don't use them at all. You just copy them down just like they are off the table. Okay, not quite done with this one though yet, because look, 2 and 4 are our charges from here. This is where they came from. They will reduce, okay? 2 will go into 2 one time. So that means there's going to be nothing here because I'm going to reduce that to a 1. And then 2 will go into 4, not that 4. That 4 came with sulfate. Don't mess with that 4. This 4, though, 2 will go into that one 2 times. So see, 2 and 4 reduce to 1 and 2. You have to reduce it when you're done for your final answer. All right, so that's writing the formulas. Let's write a few names as well. Okay. Na is sodium. If you don't know that, you have to go to your periodic table and look it up. You'll have it. Okay. P is phosphorus. We changed the ending to IDE just like we did with our covalent compounds. Okay. If it comes off the periodic table, which phosphorus does, it's P, we're going to change it to IDE. Now, no Roman numerals on these because remember, this whole group here, this one and this whole group here does not get Roman numerals, okay? Neither do these. Only these in the middle. So sodium is here. That means he does not need Roman numerals. So that's it for that one, sodium phosphide. Very straightforward. All right, if you see a formula that has more than 2 elements in it, like this one has 3, magnesium, sulfur, and oxygen, that's your clue that there's a polyatomic ion in there and you need to go find it, okay? Well, you'll have your list to compare it to, so you'll have this to look at, okay? Well, I can see that that one is this one right here, sulfate, okay, SO4. So that's this one right here, that's sulfate. So Mg is magnesium. Magnesium, and then sulfate. Listen, do not change the names of the polyatomic ions. I changed this one to IDE because it came off the periodic table. This is a polyatomic ion, so I do not change it. So here, if it comes off of here, we change it to IDE. If it comes off of here, we do not change the name. We simply write it exactly like it is. They have special names. Okay, no Roman numerals because magnesium is in the second group. All right, Pb is lead. S is sulfur, but it comes off periodic table, so we're going to change it to sulfide. Got to change it to IDE off of there. Now, these need Roman numerals. How you decide what Roman numerals it gets is by working your way backwards, okay? So basically take this charge, bring it back up here, take this charge, and bring it back up here, right? So sulfur had that -2, and it does. You can go look it up. It has a -2 charge. That makes sense. Lead had a +3 charge. It gave it to sulfur. So that's what goes here, a 3, Roman numeral 3. If you want to make them Roman numerals, there you go. All right. Next one, chromium, and this one's tricky, okay? These like this get a little tricky, so that's why I gave you one like this. Chromium, we'll write that first. And then SO4, again, that was like this one, it's sulfate, okay? So sulfate. Now here's the tricky part of this one. When you're trying to figure out the Roman numeral for chromium, because it is a metal in the middle, you look to see what it gave the other one. Listen, it did not give sulfate this 4. Remember, sulfate had a 4 up here too. It already came with that 4. Chromium did not give that 4 to sulfate. All right, so what you do, and there's nothing here, okay? But But sulfate also did not have a 1 charge. Sulfate had a -2 charge. So when you go look up sulfate, it has a -2 charge. So I know that sulfate had a -2 charge. So when I'm trying to figure out what kind of charge chromium gave sulfate, you have to take that into consideration because it didn't give it a 1 because sulfate doesn't have a 1 and there's nothing here. So the only thing that could have made both of these be nothing is if chromium had also had a 2 charge and they crossed out like that other example that I showed you. Okay, that's the only way that they could have made CrSO4 with them both crossed out is if they were both 2. Okay, because sulfate's charge can't change. Sulfate always has a 2 charge. So you always use the other ion to make sure that nothing has happened to that metal's charge. Okay, so in this case, chromium has a 2 charge. So that is what would go right here.